In this lesson, we're going to go over compound interest. So compound interest means interest that's calculated several times over a term. So it can be compounded in a few different ways. It can be compounded annually, meaning it's compounded one time per year, semi-annually, which means, that should say 2 times per year, quarterly, which means 4 times per year, or every 3 months, monthly, 12 times per year, sorry about that, quarterly, which means 4 times per year, monthly is 12 times per year, weekly is 52 times per year, and daily is 365 times per year. So that means the interest is going to be paid out that many times per year. So for example, if you had $4,000 that was deposited earning 6% for 2 years. In the last lesson, we learned about simple interest. So with simple interest, this investment would earn 4,000 times 0.06 times 2. So it would earn $480 in interest. So if we add that to what we started with, you would have a total of $4,480. Now with compound interest, what happens is that after, with compound interest, what I'm showing you here is it being compounded semi-annually. So semi-annually means 2 times per year or every 6 months. So in this situation, what would happen is that you have your balance of $4,000. After half of a year, you would earn your 6% interest times 0.5, so the same formula, 4,000 times 0.06 times 0.5, you'd earn $120 in interest. So you would have $4,120. Now, in the next 6 months, when you go to calculate your interest, you would use that new amount. So now your principal is $4,120 times 0.06 times 0.5. So after another 6 months, you would earn $123.60, meaning your new balance would be $4,243.60. And you would continue going like that. So every 6 months, you would take your new balance and multiply it by your rate and your time again. And you'll see that at every increment of time, you're earning a little bit more interest each time. That's because you're earning interest on top of the interest that you already earned. So you can see here, after 6, 12, 18, 24 months, or 2 years, your investment would be worth $4,502.04. Compared with simple interest, which is $4,480, you can see you earn a little bit more interest. Now, the longer this investment lasts, the more and more interest, or the bigger the difference would be between the simple interest and compound interest. Now, it's a lot of work to set up a table like this every time you want to calculate interest. So instead of having to calculate it at every increment, you can use the compound interest formula. So the compound interest formula is this one here. What this formula is it says that A, or the amount at the end of the investment, so this is the total amount you would have, is equal to the principal, so what you started with, times 1 plus your rate, again as a decimal, over n, and that needs to be the number of compounding periods per year. So you can use that little chart at the top of this page to find your n value. Over n, and then to the power of n, so the number of compounding periods per year, times the time. So a couple things to remember is that your rate should always be in a decimal, and your time should always be in years. So let's try one. Hugh invests $2,000 at 3.5% over 5 years compounded monthly. determine the value of his investment. So we're looking for, oops, this letter here should say A. A is the future value. This is the unknown. The principal is $2,000. That's what he's investing. The rate is 3.5%. So remember, divide that by 100 and you'll get your rate of 0.035. N is the number of compounding periods per year. So this is compounded monthly. That means every month. So the number of compounding periods is 12. And the time is 5 years. So when we put this into our formula, A is unknown. It's principal times 1 plus the rate over N to the power of N times T. Now, in your calculator, when you type this in, you want to make sure that you're doing 2,000. Sorry, there's some errors in this book. This first one should say 2,000. Just switch it out. 2,000 times 1 plus 0.035 divided by 12, then close the bracket, to the power of, so this is what the power button looks like on most calculators, open bracket, 12 times 5. So you want to make sure that this exponent is in brackets. And when you do that, do that on here, 2,000 times 1 plus 0.035 over 12 to the power of, open bracket, 12 times 5. And you'll see here that this equals $2,381.89. So an investment of $2,000 after 5 years would be worth $2,381.89. Now, compound interest when you're earning money allows you to earn more interest, but it also means that if you had a loan, it means you would pay a little more interest than if it was a loan with simple interest. So if we use the same formula, we're going to determine the amount that would need to be repaid for each of the following. So the first scenario is Jennifer borrows $7,000. She has to pay 4% simple interest and has 3 years to pay back the loan. So we just want to calculate how much she would have to pay in interest. So this is simple interest, so I'm going to use I equals PRT. So remember, the principal is how much she borrows. The rate is the decimal version of your percentage, and the time is the number of years. So the interest here would be equal to 7,000 times 0.04 times 3 years. So this would be $840. Now remember, with simple interest, this formula gives you the amount of interest. So to find the total, you would have to add the principal plus that interest. So $7,840 would be the total amount paid for this loan. Now if we compare that with the second scenario, where we have Rachel who borrows $7,000 at 4% interest, but now it's compounded monthly, let's see how much she would have to repay. So again, 7,000 is your principal. Your rate again is 0.04. Now, in compound interest, we also need n, which is the number of compounding periods. So that's 12, and her time is 3 years. So our compound interest formula is A equals the principal times 1 plus the rate over n to the power of n times t. So in your calculator, you've got 7,000 times 1 plus 0.04 over 12, closed bracket, to the power of, open bracket, 12 times 3. So we get a total here, $7,890.90. So what you'll notice here is with compound interest, she's going to pay about $50 more. So overall, the loan that will cost more will be Rachel's loan. And that's because she's charged compound interest.